All right, 2.4. In 2.4, we're talking about biconditional. Okay? Biconditional. That means it goes both ways. Okay? That's all. All right, so number 11. Write a conditional statement and the converse. Okay? So we've been doing that already. I've been making you do that already for a reason. They haven't been asking you to, but I've been doing it because why not? The more you do it, the easier it will become. Right? So, a parallelogram is a rectangle if and only if it has 4 right angles. Okay? Remember what I said about if and only if. Okay? If and only if, so this is number 11, it has 4 right angles. Is that what it said? If and only if it has 4 right angles. Okay? If 4 right angles, then what? Then what? It's a parallelogram? Huh? What? No, I'm doing it right now. Different page, 2.4. We did 11 on 2.3. You're right. Sorry. This is 2.4 11. So we're doing two homework assignments. All right. All right. So it's a parallel. The parallelogram is a rectangle. So the parallelogram. This is how you say a parallelogram. Is a rectangle. Okay? So, that's your conditional statement. Let's just have some fun here. Is that true? Is that true? In other words, if right, then rectangle? I don't want to put an R again. Can't say square. Perpendicular. That's the same as right. So if right angles, then rectangle. Let's just say, okay? So if they're right angles, or perpendicular angles, right, then we have a rectangle. Is that true? If your parallelogram has right angles, then it's a rectangle. That's true. Okay? Can it go the other way? If it's a rectangle, then they'll all be right angles. Is that true? Yeah, that's true. So what can we say? We could say if all are right angles, then it would be a rectangle, and it's a biconditional. Meaning it goes both ways. Okay? So you notice how I wrote a little bit more information up here? This is what I would do in my notes, because then I can read it. If the 4 right angles, then the parallelogram equals a rectangle, or is a rectangle. Right? I can read that as a sentence. It's really hard to read these as a sentence, but it's a lot easier to change these into converse, inverse, right? It's a lot easier to use law of syllogism on them, because you'll see, oh, if R, then T, if T, then Q, then R, then Q, right? If it doesn't go in that order, it doesn't work. Law of syllogism doesn't work. If you say if R, then T, if B, then Q, then R, then Q, you can't, no, that doesn't work, right? Because B and T have nothing to do with each other that we know of. See what I'm saying? You can't say if B then Q, if C then R, and then therefore if B then R. This doesn't work. Because this C, I don't know what C has to do with Q. And you'll see that right away, right? Whereas if you see something where it's if B then Q, if Q then R, you could say if B then R. You see what I'm saying? That works because of the law of syllogism. It only works if these statements are true, though. That's the law of detachment. And then we're getting in the point of, well, this only works if this is true. So you have to ask yourself, is this true? Yes. Is this true? Yes. That's your whole law of detachment. Okay? Then you can start saying, okay, if this is true and this is true, then this is true. So it goes both ways. Okay? Alright. I'm going to get rid of this part because that was just kind of an added little gem. Alright, 13. For each conditional statement, write the converse. Write the converse. And a biconditional statement. Okay? Basically what we just did. So, if today is Saturday or Sunday, then it's the weekend. Okay? So 13 says if today is Saturday or Sunday. I'm going to go with S-U. S-A-S-U. Okay? Saturday or Sunday. Okay? Or let's just go. Let's go A and U for Saturday and Sunday. Right? The second letters. Okay? Then what? Then it's the weekend, right?
Yeah.
Okay? Is that true?
Yeah.
Okay. That's true. All right, let's write the converse. What's the converse?
Isn't that the opposite?
Not the opposite, but the flipped.
Oh, the flip.
Think about it like when I think of opposite, I think of negative. And if I think of negative, that's the inverse. See what I'm saying?
So then it's like if it's the weekend, then it's Saturday.
If it's the weekend, then it is Saturday or it is Sunday. Is that true?
Yeah.
Yeah. Okay? So then what's the biconditional statement there? If A or U, then what?
Then it's the weekend.
Yeah, and the then goes both ways. It's a biconditional then. The then goes both ways. Pretty easy stuff. Could you do this on the test? Right? Okay? Alright. If you're not listening, if you're not here today, are you going to be able to do this on the test very easily?
Probably not.
No. It's kind of like that Dakota statement, right? You know, if you're not watching those current events, then your test scores probably won't be as good. Okay? So, same thing in here. Even though this is easy, it's only easy because you're paying attention and you're trying. Okay? Now, some of people, this isn't easy for. That's why I keep asking you. Thumbs up, right? If you're getting this, thumbs down, thumbs left. Because the logic brain, not everybody has a logic brain. Okay? So not everybody thinks logically. You understand? So it's harder for some people. But like a logic professor told me when I first took the classes, there's basically 3 grades in here. An A, a C, and an E. And back then, E's were F's. Okay? At some schools. Okay? So an E, an A, a C, or an F. 3 grades. A person whose brain works logically, a person whose brain doesn't work logically and struggles to get a C, and then the person who doesn't give a damn. Because if you just care a little bit, you should at least be able to get a C in this class. Okay? That was his idea behind that. You know? But it is tough for some people. So if this is tough for you, let me know. I'll try to help you. Okay? Alright, 15. If a triangle contains a right angle, then it is a right triangle. Okay? Let's see. 15. If a triangle contains a right angle, then it is a right triangle. Okay? So let's write it out a little bit more before we do this. So if a triangle contains a right angle, then the triangle is a right triangle. You see how I'm writing that? I'm making sense out of the words. I'm turning the words into symbols. The one symbol that you may not understand is contains. Okay? That means contains. I don't think we wrote that down last week, so you might want to write that down. Okay? Also can mean such that. Such that is usually the other way. That's how I learned it. Okay? But, so they're saying contains. Alright? Okay, so they're saying if a triangle contains a right angle, then the triangle is a right triangle. Okay? So in other words, I'm going to write this as a statement. If the triangle, then it's a right triangle. If the triangle contains... So I'm just kind of breaking it down so I can see if law of syllogism works. So what this is representing is all of this. Does that make sense? So this represents this, and this represents this. Okay? And from there, I can go, well, can we write it the other way? Can we write it the other way? Okay? If R, then triangle. So, if the triangle is a right triangle, then the triangle contains a right angle. Is that true? Right? Yeah, that's true. So because both of these are true, we can write the conditional statement, the biconditional statement, which is if triangle, then the right. So if the triangle contains a right angle, then, and then is a biconditional then. A biconditional. Okay? Then the triangle is a right triangle. This is what I want from you guys. Okay? Seriously. I want you to know how to take notes with symbols. This is going to make your life so much easier for college. Because you can start to write in symbols, or what we call shorthand, versus having to write all the words that the professor is saying to you. Okay? It just goes quicker. Alright, next. That was 15. Let's go 17. The number 2n is even if and only if n is an integer. Is that true? Okay? Okay? 17. It's giving you the then. It's giving you the then first. Right? It's saying the number 2n is even. So 2n is even if and only if n is an integer. Okay? All right, let's think about that. First of all, if n is an integer, then 2n would equal an even number. Is that true? That's the same biconditional statement, right? This is the actual biconditional statement. Or not, sorry, not biconditional. This is the actual conditional statement, right? Made out of this, because this is your conclusion. And this is your hypothesis. It just came out of order, right? So we put our hypothesis and then our conclusion. That's what a conditional statement is, right? And then we ask, okay, is that true? 2 times any number, any integer is even. So 2 times an odd. So 2 times 5 is 10. 2 times 7 is 14. What about 2 times an even? 2 times 6 is 12. 2 times 8 is 16. Does that work? So this is true. So we don't have to give a counter example. Okay? Let's look at 16 just for giggles. Okay? 16. It says Philippe is a swimmer if and only if he is an athlete. Okay? So in other words, if he's an athlete, then he's a swimmer. Is that true?
No.
No. Because you can be a lot of different things as an athlete, right? Okay? So this is false. And then you would give your counter example. What's your counter example?
Those different sports.
Yeah, if an athlete, then you could be a football player, right?
Or
Or
a wrestler.
a wrestler. Or, and ... right? It just goes on and on and on and on. It could be anything. Okay? Preferably, I want you to write that out in words, but I'm lazy, so I said it to you. So, but yeah, just tell me, an athlete could be a wrestler. That will be on the test. Okay? Does that make sense? Counter example. Alright? What's next? 18, 19? How far are we going? 25? Should we take a pause? Let you catch up and then... Okay? So we'll take a pause.